Have you ever looked at an AI's answer and just wondered, is it actually thinking or is it just an incredibly good actor? Well, we're starting to see this new wave of AI that doesn't just give you an answer. It actually shows its work, laying out a whole thinking process. Today, we're going to tear down a fascinating new research paper that puts these models to the test. And let me tell you, the results are, well, they're not what you think.
So here's the big question this all boils down to. When you take these AIs that are supposedly reasoning and you push them way past the kinds of problems they've seen all over the internet, what happens? Do they actually reason their way through it? Or is that whole illusion of thinking just start to fall apart? Let's find out. All right, let's dive right in. First things first, we need to meet the main characters in this story, a new class of models called large reasoning models, or LRMs for short. And these are a whole different breed of AI than what we might be used to. Probably the easiest way to think about the difference is like this. A standard large language model, an LLM, is kind of like a student who just writes down the final answer on their test. But an LRM, this thinking AI, is like the student who shows you every single step of their work. It literally generates this detailed internal monologue before it ever gives you its conclusion. So, to get a little more technical, we're talking about models like Anthropic's new Claude 3.7 Sonnet Thinking or DeepSeek R1. They use these special techniques, like chain of thought, where they reflect on their own steps. The whole idea here is to mimic a human-like step-by-step reasoning process so they can tackle tougher problems. But the huge question still hangs in the air. Are they really thinking? And that brings us right to the heart of this investigation. How on earth do you even design a test that can tell the difference between genuine, flexible reasoning and just some unbelievably sophisticated pattern matching? The researchers really nailed the question here. Is what we're seeing generalizable reasoning, the ability to apply logic to totally new situations, or is it just a fancier kind of pattern matching? To figure that out, they first had to realize why all the usual tests, like standard math benchmarks, just weren't gonna cut it. You see, the problem with those standard tests is that they're messy. First off, you've got data contamination. The model might have secretly seen the answers somewhere in its mountain of training data. Then there's the fact that their performance is just bizarrely inconsistent. A model could ace one math test and then completely fail another one that seems pretty similar. And finally, you just can't smoothly turn up the difficulty knob. So the researchers came up with this really clever solution. They created a kind of clean room for their experiment, using classic logic puzzles. Think Tower of Hanoi, river crossing, stuff like that. With these puzzles, the rules are perfectly clear, there's no way the model has seen the answer before, and you can control the difficulty with absolute precision just by, say, adding one more disk to the tower. Okay, so let's get to the results, because this is where things start to get really weird. After running all these tests, the very first thing they found was a huge surprise. It wasn't as simple as the thinking AI is just better. Nope. The results split into three very different, very unexpected groups. And here it is, the first big shocker. For the really simple problems, the standard non-thinking AI was actually better, more accurate, and faster. The thinking model had this tendency to overthink things and trip itself up. It was only in that middle zone of complexity where the thinking models really shined. But then, once the problems got really hard, something dramatic happened. They both just failed. Completely. And this failure, it wasn't some gradual slide in performance. It wasn't a slow decline. It was a total, sudden collapse. And this, right here, this is the smoking gun of the entire investigation. The researchers have a great name for it, the performance cliff. It's not that the model started to get more answers wrong. It's that their accuracy on these puzzles literally fell off a cliff and dropped to zero. Nothing. It's like a circuit breaker just flips and the lights go out. And this wasn't some fluke. It happened with all the top models on all the different puzzles. For example, for the O3 mini model, once the Tower of Hanoi puzzle hit 8 disks, boom, game over. For Claude 3.7 Sonnet, the checker puzzle broke as soon as it hit 8 checkers. It was like hitting a brick wall. But here's the part of this collapse that is just completely backwards. You'd think that as a problem gets harder, the AI would think more, right? It would use more of its brain power to try and solve it. Well, the exact opposite happened. As the models got closer and closer to that performance cliff, they actually started to reduce their effort. They produced shorter and shorter thought processes.
It's almost like they knew they were in over their heads and just gave up.
So why? Why is this happening? To figure out the motive behind this bizarre collapse, the researchers decided to peek under the hood and look directly inside the AI's thoughts by analyzing those step-by-step reasoning logs they produced. So this is a little peek into what that actually looks like. You can literally see the model making a plan, listing out moves, and even saying stuff to itself like, let me double check this. But what happens when you dig through thousands and thousands of these internal monologues?
Well, a really clear pattern emerged, and it perfectly explains those three regimes we saw earlier. On the easy problems, the AI finds the right answer pretty fast, but then keeps thinking, exploring wrong ideas, and often confusing itself. That's the overthinking. On the medium problems, it struggles, goes down some wrong paths, but eventually manages to self-correct and find the solution. But on the hard problems, it never finds the right answer. Not even once. Its ability to self-correct just isn't strong enough.
And that brings us to the final act of this whole investigation, which honestly has some of the most baffling twists that really make you question what we even mean when we say an AI can reason. Okay, this next finding is just wow. It's an absolute bombshell. The researchers literally gave the models the exact step-by-step instructions for how to solve the Tower of Hanoi. They didn't have to figure out the strategy. They just had to follow the recipe. And they still failed at the exact same point. This suggests the problem isn't just about strategy. It's a deep, fundamental limitation in just following a long series of logical steps.
And you can see this wild inconsistency right here on full display. On one puzzle, the Tower of Hanoi, a model could successfully make over 100 correct moves in a row before it messed up. But on the river crossing problem, that same model would fail after just 4 correct moves. 4! This really suggests its reasoning isn't some general skill, but it's highly dependent on specific patterns it may have memorized. And all of this leaves us with this final, really tough question. If a cutting-edge AI can't reliably follow a simple set of rules it's been handed or apply logic consistently from one simple puzzle to another, can we really say that it's reasoning? Or is it all just a very, very convincing illusion of thought? The evidence from this paper suggests we still have a long, long way to go.